So without further ado, I want to invite the speaker of the day, who is Danvit, who will take us through learning that, and hope kila mtu atalearn one or two. Asanteni sana. Danvit, can you get me?
Yes, I can. So guys, welcome to... Can I be heard?
Yeah. I can hear you very loud and clear. Welcome, Danvit.
Okay, thank you. So as part of our gentle introduction to Flutter, one of the things that you need to understand a bit of before you go to Flutter is that is the language that powers Flutter. So just today's talk will be a bit technical, and I'll be going a bit fast. So just a gentle introduction to Flutter. Flutter was released in November 2013, so it's quite an old language. It was founded within Google by Lars and Casper. So it's a very modern language. Initially, it was thought of kind of like TypeScript, where it was meant to somehow replace JavaScript or transpile to JavaScript. Before Flutter came along, actually people were thinking that the language is dead, since somehow TypeScript beat that to that niche of transpiling to JavaScript to develop mobile apps that to develop web apps that are at least safe. Development becomes a bit safer if you use TypeScript or that. So at that point, before Flutter came along, that was somehow going down in terms of usage. Then I think one of the biggest things that brought it back was Flutter. So it's a very modern language. It's built on the foundation of other languages. Basically, all these languages that have been in existence since programming started, like C, C++, Java, and JavaScript. Basically, as they went along, there came a bit of challenges and or restrictions to the languages. So that actually, the advantage of that is that it stands on the shoulder of giants. Basically, it takes the mistakes of these other languages, which it's very hard to correct a language once you've developed it because there's compatibility issues. But building a new language, it actually started with solving the problems that all the others have faced. So that has both two compilers. That is a compiled language, so it compiles to machine code, and that's one of the reasons why what makes that very fast. So it compiles to machine code, and it has two compilers. It has the just-in-time compiler and ahead-of-time compiler. Just-in-time compiler is used during debugging. It's very fast. Basically, it can do things very fast, but it produces a very big compilation output. The advantage is that it powers things like hot reload. Ahead-of-time compilation is used when you're publishing your app, where it will now, everything will be optimized to run very fast on mobile. You will see while developing Flutter that some of the things will take a bit of time when you're in dev mode or you're in debug mode, and when now you come to run the same app in production mode, you'll see that it's basically very, very fast. So today we're going to do a lot of code. So that was just one slide I wanted to share. It was from a previous slide. Here is a fun bit about that. As Python and Java are basically, as Java and Python are being used to make Kotlin, actually that is copying a bit of Kotlin. And actually one of the other languages that it's actually coming close to is also Swift. So it's a very modern language that builds on other languages. So to compile that, since we're not doing Flutter yet, so how do I like compile that? In the previous session, we installed Flutter, which came with the Dart SDK. So if you have your Dart SDK installed, all you can do is that if you have some code here written in Dart, you can just run that, then the name of the file, and it will compile and print whatever basic, and compile the code that you have in your file. So the main entry point of that is the main function. So in every that app you'll be working on, there'll always be a main function which calls other function if you have other functions. And here we just have an example of a main function with 2 print statements, which is just welcome. And also it uses imperative programming. So that means that the lines are sequential in execution. So you'll have this and that. So since we have quite a short time, about just 40 minutes, so I'll not use this because it will require me to write commands every time. So what I'll do is that I'll move over to this Dartpad. Dartpad is basically an online compiler for that. You can just use, if you want to test that and see how it works, the best place to start with is here at dartpad.dev. So just give me a minute. So see, I had prepared some script ahead of time, so I'll just be copying from it and basically trying to explain 1 or 2 concepts to us. I think, do we have non-programmers in the, anyone who is a non-programmer? Hello, can you guys still hear me? Hello.
Hey, we can hear you, Danvik.
Okay. So is there anyone who is a non-programmer here, so that we can know how we can basically tailor the concepts that we are trying to learn? Anyone, if you are a programmer basically, or you are just starting out, you can. Oh, nice! I see one person here. So I believe for the non-programmers, most of the concepts you'll find here are just as easy. If you've done any other language, I usually don't spend a lot of time teaching people programming languages, because once you get the programming concept, all you need to do is just move from one language to another, and there's nothing very big to it. So for the non-programmer, I think I've tailored it to this session to be a bit of both, where you can, whether you are a non-programmer or you're a programmer, I think you can still benefit from it. So, and I'll be going a bit fast. So since the session is recorded, you can take your time later on and go through whatever we went through. So every variable in, let's just copy this. Second screen is not working correctly, so you'll just be seeing my. So basically, every variable that so var x is basically just describing, declaring a variable x, and we're assigning -10 to it. So you'll notice that every function in every variable in that is actually sorry about that. That's an error. Great. So every variable in that is an object. So this is something that you'll come to appreciate in future. But just to test and see that to confirm that this is an object, that -10 actually is an object. It is not just a primitive integer. You can just even put a dot next to it, and you will see that I can be able to do something like, we can take the absolute value of -10, which will just be 10. Or if I have another variable here, let's say var y is equal to, let's say 20.5, I can just do a dot there, and it will basically, I can be able to do all the double functions by like getting the, basically rounding the figure or whatnot. So you'll notice that x and y and actually 10 and 20 are actually objects. And this is very fundamental in understanding that. So when it comes to that, there are several types. So let me just copy fast. So there are several types of variables in that, or types. So we have numbers, which include integers and doubles. We have strings, we have booleans, which is basically just a true and false type. We have lists, which in other languages you'd call arrays. We have maps, we have runes, and we have symbols. Runes and symbols, those are a bit esoteric, and we'll not cover it. We'll just cover the basics. So just to declare an integer, you can say int x is equal to now, and then assign the value. So you can either do int x or do var x. Var x, like the way we did in the previous example, we saw that there was no compilation error. So the issue is the compiler, the DAT compiler will actually infer the types that you're trying to put, and basically know that you put 10, that is an integer. You put 10.0, that's a double. So you don't have to actually assign it. Then there's strings. So for a string, we have something called interpolation, where you can even do calculations inside the string. Let's say, for example, we have like 10 and 10.0, which will be like equates to 20. So this is string interpolation, which just shows an example of a string. You can print it. So let's just run this code and see. So we can see that we have true as a boolean. We have a list. This is basically a list of integers. You can declare it as a list and give it a name like that, or basically say list of int, which obviously the compiler can do that for you. You don't have to specify, as long as the types are the same. In that list, you don't have to specify. So for a list, it's just like an array. If there's anyone who is interacted with an array in another language.
Sorry, a minute, David.
Okay.
Sorry to interrupt. Can you zoom it a bit? It's a bit strenuous for us.
Okay. That better? Ian, is that better?
That's better.
Okay, so so we have here a list of strings. We can either describe the type, or you don't have to. So just like an array, for the first element of a list is at index 0. The second element is at 1, 2. So it starts from 0. So so if I use the square brackets and specify I want the list, the element at index 0, you'll see that it will print 1 in this basically this is the one that equated to this. So it will print 1, since 1 is that at the 0th index. And you'll see here we have a list of strings, and at the 0th index we have 1, at the first index we have 2. So that's why it has printed 2 here. We also have maps or hash maps in that. So when declaring a hash map or a map, So the first we'll put the angle brackets to indicate you want to specify the types. So what's interesting about that part is that while trying to do this, it's actually helping me understand, basically explain this. So it basically just contains key value pairs. If you are doing Python, it's something like a dictionary. Or if you're doing JavaScript, it is like a JavaScript object where it has a key and a value. So when describing it or when declaring it, you say like the first variable here will be now what is the type of key. So you can see here like the keys are strings and the values are integers. So this can be anything. You can even have a map of we can even have object here, any other kind of object. And as we said, everything in that is an object, or every variable in that is an object. So as we have here, you can so to specify a given value that you want to access. To access, you use the square brackets and you use the key of the map to access the value. That's why we have 10 here. So those are the main types of Dart objects. So next we'll look at functions. So functions in Dart are actually, so let me just copy this first before I can start explaining. So in Dart objects, a function is also an object. So by saying that a function is an object, it actually means that you can store a function inside a variable. Basically, this is what in other languages in like JavaScript they say they are first-class functions. They are first-class citizens of the language. Basically, just like a string, you can store it in a variable. You can also store a function in a variable. You can pass it as a parameter to another function, and this is a very powerful thing in modern languages, where functions can actually be passed around. Sometimes you don't need to declare a function here and use it. Maybe just use once. So let me just instead of declaring somewhere and then referring to it, I can just save it as a variable. And that's a very powerful thing. It can be stored inside any data structure. Like you can have a list of functions from which you can call any function inside. So we'll just run this code and see what it evaluates to. So we have our main function running add 1 plus 2, which is 3. So basically, it will just pass these parameters to the function, and the function will evaluate. So you'll see that you can do calculations like this, but the problem with this is that in our example here is that we have not specified the types. So here, if we try to run, actually the last object is not being evaluated because you can't do an addition of true and false. That doesn't evaluate to anything. So it's good to always specify the types, because if you don't specify, it will be taken as dynamic. Dynamic means anything can come in and go. So the problem with that is that true plus false, what does it evaluate to? You'll have problems. So first of all, we have to appreciate that the best thing to do is actually to declare the types, so that in case declaring the types is actually advantageous in any language. Because if you have an error, actually the compiler will help you solve the problem. So we have here, we are trying, our addition is supposed to be between integers, and we are providing doubles, we are providing strings, we are providing booleans. So that is wrong. It's very good to specify the types, because if you don't, the compiler has to do it by itself. and that chops off a bit of compilation time and actually memory usage, as we'll see in future. That memory usage, it will actually depend on the types that you are trying to declare. So this means that all these other statements are wrong because they are not conforming to the types that we want. So if we run that, we can see that there are no errors and everything is compiling correctly. So the next thing we are looking at is, so basically, how do we use functions as variables or something like that? So let me just minimize this so that we can have our topics well stated. So let's take this script here. So as you can see, we can actually just, let me remove this and let's just use a function here. So as you can see, we can declare a function as a variable. Like this add is actually stored inside this variable. So instead of saying add, we can just say fun. We can just use this function and give it the values 20 and 30. It's just the same as calling add 20 and 30. So we can just duplicate this line. Sorry. We can just duplicate this line and actually just also interpolate here and do add 20 and 30. It will just evaluate to the same. So both of these will return 50. Sorry, here I duplicated that. So you can see, since this variable this function we had stored it inside a variable, you can just call the variable and give it parameters and it will execute that function for us. You'll notice that when saving a function as a variable, we don't put the braces. Braces means start execution, which we don't want to do. We just want to save it first, and then we can execute the function itself, the variable itself, instead of the function directly. So this is a very powerful thing, and you can see we'll start passing functions as parameters inside functions, and you'll see how powerful it is. And especially when it comes to Flutter, you'll notice that it's a very powerful concept. So you can also use variables as a parameter, as we said. So here we have it. So let's say, for example, we have this function called exec. You give it a function and you give it parameters depending on the functions you give it. Let's just also duplicate a line here, and let's do a subtraction. So let's call it sub. Sorry. And then do -v. So depending on, so you can just copy this. Into a sub here, and then give it 10 and 20. So we can call it this results too, so that we don't have conflict in naming. So let's just call it results 2 and try to run. So as you can see, the first result, we've given the function exec a function, and we've given it the parameter that it needs to do. So this will make your code very reusable. I don't have to specify, I don't have to like declare the whole function when I need it. I can just call it here, and this takes a function and then the parameters that it will be working on. And you can see subtracting 20 minus 30 is -10, and adding 20 plus 30 is plus 50. So that just shows that you can use it as you can pass it as a parameter to another function. So next, you're looking at inline functions. Basically, an inline function is just like any other function. So you see, for example, this function of ours takes three lines to declare. But if you on what you're doing is only returning a value after evaluating the function, you can simplify the statement. So let's simplify it to so I'll take the rest of the functions. So when executing main, now we can even choose between this and that, and basically you can just call it, you can call a function. Basically it's here we are returning a function as a return type. These two functions which we've simplified. So this subtraction is supposed to be negative here. So as you can see here, we are passing a Boolean to this function and it's returning a function. So the function that we return, we can actually just call it directly from there, or you can do it two ways. Let's try. Let's call this fun. Then since fun is actually just whatever choose returns, and it returns here a function, we can now do something like fun of 20 and 30, and depending on which choose will the function choose will evaluate to whether it's subtraction or addition. We will actually be able to display whichever function. So here the function is being returned out of a function, another function. So the next concept will be storing functions inside other data structures. So let's just evaluate it here, see how it works. So as we said, we have lists, but we can have a list, basically a list of functions. Let's say, for example, you want to have different functions, and depending on the index of that list that someone has chosen, you want to do either addition or subtraction, or we can even like create more functions to do multiplication, division, and any other thing that you want to do. So here we have a list of operators. So the operators are the functions that we are trying to get. So depending on the type, if we say like operators at index 1, which is the subtract, since it starts from 0, this is 1. So we can give it. So basically, this will be the same as subtract 10 minus 20. So I think I made a mistake here. So let me just correct it before we run. That will get garbage in, garbage out. So depending on the function that depending on the index that we've given it, it will return a function, and we can call that function with these parameters. Calling a function is just as simple as putting the braces and like putting the parameters that it will require. For this, it's integer and another integer. So if we say operators at index 0 and do 10 plus 10 and 20, it will do addition, since in the list add is that the 0th index, so it will evaluate to 30 should. So that is how it works, using functions inside other data structures, which means that you can actually store your functions inside anything, so that in case, depending on the type of information you want, you can fetch a function and the function will do the calculation for you. So there's one other thing called anonymous functions. So let me just. So as we said, we can do, let's just start simply. Print. So let's create another variable here called fun. It will take a function is equal to, it takes AB and returns and prints the function. So we can just basically do a fun and then call it with our parameters. Just call that function, since the function also you have to terminate here. So call it this way, and it will evaluate to that. So you'll see that there's since the word function is basically we're just using it and calling it once, and that we are done with it. We actually don't have to waste the memory of declaring inside a variable. So we can just like call it directly. And you see this function of ours doesn't have a name. So that is what we call an anonymous function. An anonymous function, you remember the ones that we had before were plus or add or subtract. But here in this instance, we have a function that we're just storing directly inside a variable. So we don't have to give it a name. So that is what we call an anonymous function. So an anonymous function, you can do that, or you can even call it directly by just appending the parameters to it, given that we've written the function itself and we can pass the parameters to that function. So invoking that method is just basically, we're just appending braces to it and giving the parameters inside braces. And this is still valid code, and it will still evaluate to the same function, to the same result. So the next thing we're looking at is, let's try to understand what an object is in Dart. So here we have a list of basically anything that is there. We have a list that has inside integer, a string, a double, a boolean, a function, a symbol, a rune, another list inside it, another map inside it. So in that, this is valid code. You can actually store any type inside a list. It doesn't have to be like other languages. Let's say, for example, Java, where you have to store, if it's a list of strings, it's just a list of strings. But there's a disadvantage to this. If you do this, the function will not know exactly this list is a list of what, so it will just assume it's a list of objects or a list of dynamics. So dynamic means like it can be anything at any one point, but this is not a good practice in that. So you'd rather have you store your list in like a specialized list by a given type. Let's say a list of integers, a list of this, because you may try to access a given type. Let's say you're trying to add something and you select a function instead of an integer, that will fail. And also, since you've declared it as a dynamic, that means that the compiler at runtime, it will have to decide what type do I want to use here, which is not very good in terms of execution time and in terms of memory usage. Because a variable is just a storage bucket in memory, if you put dynamic, it will not know how to assign how many bytes do I want this storage bucket to have. And that is a very big disadvantage. If you say an integer, it knows an integer will take this amount of length. But if you don't specify at all, that means that the compiler will put as much memory as it can, so that depending on whatever type you're trying to put in, it will actually just choose at random. So you'll notice that this still is an okay function that still works. But just a rule of thumb, always specify the types. So next, we'll look at string interpolation. String interpolation is something that you will come to appreciate in Flutter, because it allows you to do that. So actually, we don't even need to do that. I think So basically, with string interpolation in that, you can do even calculations inside strings, because all we don't have to write a function to do x plus y. So all you can do is just put it as part of a string, and you'll see this in when you want to print something on a screen for Flutter. If you want to put something on a package, let's say on an application, let's say for example you're trying to have someone's name. So instead of trying to say, let's just do it as an example here. Let's say we have variable first name is equal to John. And another variable here, last name, let's call it lname, and let's call him Doe. So let's say, for example, we want to print their name. We want to have in our console here the name. So we can either do print fname, then we can do a plus, then put a space because we want to have the first name and second name. Sorry, and do a plus, then lname, so that we can have the first name and second name printed together. Let's just do it that way. So we have here John Doe, but this is it is not very clean code. It's very it's not appealing code. So what we can do here is we can do string interpolation, which basically we can have it this way. And remember that if we don't specify, if we don't put a $sign before the variable, it will assume that that we want to print the literal string. So let's call it this full name so that you can just see a difference between that. So let's say you see this looks cleaner because the string interpolation makes it very easy for us. String interpolation also allows us to do calculations inside a string. As we said, we can even call a function inside a string. We can place this. We can place the braces here, but it's not necessary for a simple string to have braces. It's not very necessary. If you want to do a calculation, then it would be better to now use the curly braces, because you can call a function and whatnot. But just for a simple variable, you can just call it directly, and it works. In case of a calculation, then you put it inside braces, and that calculation. In fact, if you remove this, you will see that this is how it will evaluate. It will say 1.4 plus 2 basically equals 1.4 plus y, because it's not doing the calculation here. It's just assuming you want x here, and plus y will be a literal string. So if we do this, now it will evaluate whatever is inside the braces and give a value, and you'll have the answer there. So next, we'll look at equality, basically how to test and see if values are equal. So yeah, the compiler is actually helping me. So double equal is just to used to compare two variables. So if you say 1 double equal 2, that will return a false, because it's not 1 and 2, they are not equal. So not equal is written in that way. It is the exclamation mark, then equal, greater than just like math, less than just like math, greater than or equal to, then greater than, then less than or equal to. Then negation, you can just do a negative. You can just do a exclamation mark before it. So if you say negative true, or basically we say exclamation mark true, then it becomes false. Exclamation mark false, then it becomes true. Basically, it just negates whatever we had before. So you'll see that we have here booleans t and f. So if we say if not f, then print the negative false. So basically, not f. If f is false, not f is true. So it will print this, and this will never be printed because even my compiler here has noted that this will not be evaluated because the compiler will never reach here because already negative false is true, and this line will be executed, and this one will not be executed. So this will be executed, and here the value of local t isn't used. So that is how intelligent that is. It will detect variables that you're not using and whatnot. So let's get rid of this so that we can see the rest of the evaluation. So 1 is less than 10. So if we do this, then this will be printed. But remember, if we say else if, so given that 1 will never be greater than 10, and it will always be negative, it will always be less than 10, this will always evaluate. But if you want to execute all this, you can basically just remove the else and have it this way. So this is basically just control flow in Dart, just similar to most of the other languages. So if 1 is greater than 0, this is how it evaluates, and we say okay. So if -1 is less than 0, so also this, in this case, since we split up and the else is not there, it will just be able to print. So next we'll be looking at the switch statement. So the switch statement is used if you want to evaluate one. If you want to basically evaluate one variable, and depending on the type of the variable it has, or depending on the value it has, go a different way. So for example, we have a switch s. This is one way. Like you see, it doesn't make sense for us to say if s, let's say for example, if s equals circle, then we print this. Sorry, I have made a mistake there. So let's say, for example, we put this. Else if it is, okay, this one's supposed to be a square. See, this code is not as, let's format. Let's just do this ridiculous option here and see why actually the switch statement makes sense. If s equals to a circle, then print take that example. If it's a rectangle, this will also work. It's just that the code is actually ridiculous because it is longer and we're just evaluating one variable. So let's format it first so that it looks better. So this is the same as this, but this one looks cleaner because we know we are evaluating s. There's no need for us repeating s, 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 s. So instead of using this, which is a ridiculous and long method, just to show that it will work the same, let's try to run that. So same, it will take a circle, and if we have something here that is actually not part of that list, then it will evaluate to no match for both. But we use a switch because we are evaluating just one. So the next thing we'll be looking at is basically combining cases. So for example, inside a switch statement, if you have, so if we have a different, we want it to evaluate. Let's take an example of age so that it makes sense. So let's use age. So if in case it's let me just use some random values here. Let's say it's teenage adult. If we run this, depending on the value that we put, if we put either 1 or if we put even 2, still these cases are, so it will still evaluate to the same thing. So that's how we do combining cases in a switch statement. You'll see that if I put else, then it will evaluate to the last one. And you'll notice that after executing whatever is under, you put a break so that it exits out of the switch statement. So the break is very necessary unless you are returning, like basically if it's a function, if you are returning, then don't need to break because they have already exited. So that's that concerning the switch. These are just main programming concepts here. There's nothing groundbreaking. So next we have a while loop. A while loop will execute until this condition is met. Let me see an error. So this is how we have this is how while loop will work. Execute this condition. So we are trying to check if x is greater than 1. If it's greater than 1, then we print the x, and then we check. So basically this x minus minus is just, that's the same as x equals to x minus 1. So minus minus is just a simple, it's just a simple way of reducing by 1. On this, it will get to 1 and x is greater than, so basically 1 is greater than 1 will fail and the while loop will stop. Taking a bit of time, so I'll take a shorter time for this and that. Then we go to classes and then up. So here we have a do while loop. The do while loop executes the, first of all, it will execute the statement inside the braces, and then it will check for the variable, for the addition. So the difference between while and do while is that for and there are cases where you need it, you are guaranteed to execute the statements inside the braces at once. So for anyone who is a programmer, I know you understand the difference between a while and a do while loop. Then finally, the last loop we have is the for loop. So the for loop, the difference between this one is that the for loop is divided into 3. So instead of us doing the negative, doing the minus minus inside the value, inside the function, we have x, we are declaring the start of it, putting the condition. So it has three sections. Number 1 is initialization, where we initialize the value x. We have the condition, then the I forget. So basically, whatever we do for each of the loop, the negation that we do negative going to the next loop. So you'll notice that, let's say for example, we have a variable y. We have a variable y here, and we want to print y down there. You'll notice that y will not be able to print because everything inside a for loop, its scope is just inside the for loop. We can't access anything outside the for loop. Even x, we can't be accessed x. X only exists in the scope of the for loop. We can't print x the for loop. X can be accessible only inside. But let's say, for example, of y, if we now do a variable y, and then here instead of declaring it, we just add it and do with y here, you'll see that it will be able to actually print the last assignment of y here, which is 3, which was like this +1 for the last element, since it will be assigned on every loop. So finally, classes, and since my time is essentially over, I'll ask Ian to give me like let's say 10 minutes to just finish up. Non-nullable model must be initialized. Okay. Let's first of all just change the version of Flutter that we're using. No, it doesn't work that way. So let's have that. So here we have a class called vehicle, and a vehicle has a model, the number of tires it has, which is an integer, and a type. So here we're declaring a vehicle called the model is Toyota and the tires are 4 and it's a saloon. So try to execute this and see. Sorry about that. So non-safety features disabled for this library. Okay. This is a bit of an advanced topic. So these are just warnings. Let's ignore them for now. So basically, let's create a class called vehicle and have a vehicle has a model, tires, and type. If we run the function, it will print the model, tires, and type. And finally, you'll see here an object which is an instance of vehicle. But you see, every class, a class like this, basically it extends the object. That this is something that is done for you. You don't have to do it yourself. So by default, it extends this thing called an object, and that's how it is able to print it's an instance of y. But you can basically overwrite this function. Let's say, for example, we want if we print Toyota, we want to give us information about this instead of just telling us it's an instance of vehicle. So for that case, we can, let's just replace this. Yeah. You'll notice that also can do something called we can use something called a cascade operator. So I think that is correct. So we can, every function of that has a toString method. So toString method will return super. Super is just in this case, since vehicle extend object, super refers to object. Object to string will return of then the name of the class. But we may want to have, when we print this variable here, when we print the object, we may want a description of the object, for example. So if I do that, we can overwrite. So basically, we can override to. Overriding just means that we want to declare our own toString for this class. So which we can use to see. We can use to basically describe the vehicle. ToString is just basically used to the object or the class that you have. So here we have vehicle 1 and vehicle 2. They have the same number of tires, they have the same type, they have the same model. So for the both of them, so this double dots just means it's what we call a cascade operator, which just means take the vehicle, assign tires equals 4, then return the vehicle, so that the next, when you assign, it just also assigns the type and then returns the vehicle. That's how you do it. Instead of doing the way we did, where we had to like specify each, we can just do it in one statement. This helps us make basically cleaner code and code. So let's run. You'll see that everything is the same. Model is Toyota, model is and tires is equal to 4. But let's try to see basically if Toyota is equal to Toyota 1 is equal to Toyota 2. Let's try to check that and see what it will return. Anyone who is willing to guess? So since we don't have time, let's run it and see. So we expect, since everything here is the same, the value Toyota 1 and Toyota 2 are the same, right? But that is not how it works with objects, because objects in memory are stored in different. Basically, we have Toyota 1, which is stored in this address, and the second one is stored in another memory address. So if we just say Toyota is equal to Toyota 2 without trying to compare, it will just, you see, it does something called reference by address, reference by the value. So if you compare the two, it will just take the address of Toyota 1 and the address of Toyota memory, and that will not be equal to the other. So that's why we can now, to solve that issue, usually in a class, you can override the equal to operator. So for this case, let me just copy that. And in our class, we can come and do another. Basically, just to be clear, we can specify that this is an override. Basically, it's another function. And here, in our override operator, we just say for the operator equals, if you give us another check, if the other value is a vehicle, then we compare their specific attribute to see if they are the same. And if it's not a vehicle, then we just return false. This way, if we do Toyota equals Toyota 2 and we run, it will basically be true. Since for Toyota 1 and Toyota 2, we'll go to every instance and try to compare current object versus the other object that we're trying to compare to, then return the value. Then basically try to see if they are the same. And since we have Toyota and Toyota, we have saloon and saloon, and 4 tires and 4 tires, that is not supposed to be false. It's supposed to be true. This will come in handy when you're trying to compare objects in that, especially if you've created your own custom class. For classes like integer and double string, this is already done for you. So in your own classes, you may have to override this information and to help you evaluate. Let's say, for example, if Toyota 2 had 5, or let's say just 6 tires, and try to compare again, we'll see that now it's false. But the variable is the same inside our our objects, then we can do the function will evaluate to true. So next, let's look at constructors. So in that, if you just declare a vehicle, so let's cut this first. See, in our previous example, we declared a vehicle. We didn't declare any constructor. Basically, a constructor is a function that creates an instance of an object. So the instance of that class which is basically an object. So here we didn't declare any constructor, and yet we are able to declare a variable and set the types. But you can declare constructors here. So this is a normal type of constructor, where if we give it, sorry. So we need a main method, because we said main is usually our. So without main, this function this code cannot execute. We can just have code without main. So let's say, for example, we have this function here. So this function is this function constructor. It will take in a model, just like a normal function. It will take in parameters, a model, the number of tires, and the types. It will basically just assign to the current class, to the current object. We say this .tires is equal to the tires that have been passed, and the same, we do the same for that. And that this constructor of ours has taken 4 lines of code, just to help us also like reduce the number of declarations that we have to do. We can just declare it once and do not have to declare individually the model, the type, and the tires. So that will just evaluate to this. We'll just print the value as it is. But also remember that this is a bit repetitive. The tires that have come in from the constructor, and we're setting it to this .tires. This means the current object. So type, we are setting the model. But this is like, these are like 4 extra lines of code. So instead of this, actually just a bit verbose, we can do this same as what we had initially. So let's just return it first and comment it like that. Let me take that moment to actually introduce multi-line comments. So if you want to comment out your code, basically if you comment out your code, the IDE will not, or the compiler will not see this, assume it's just in additional information you added. So here if we do this, it's the same as this. It will just check a variable called model, and it will assign to this .model as check for basically the tires and the type, and do the same. It's just the same as this. It's just that it will make your code less verbose. So this one makes things a bit easy for you. And so that's that. The next thing we want to look at is a named constructor, and this will be our last topic today. So named constructors. For example, we know that a saloon car has 4 tires, and its type is saloon. Basically, it's a vehicle that has 4 tires, and its type is basically its shape is a saloon. And then I assume we have another vehicle called motorcycle, which has and the type is motorcycle. So instead of us declaring it like this, or let's say, for example, let's take. So instead of declaring Toyota, with specifying the model, specifying the number of wheels and specifying the type, if we have another car called Subaru, we can just a saloon constructor. This is a named constructor. So basically, it's a constructor with a name called saloon, and it will, since the type and the number of tires will not change, we can just assign this. And in this named constructor hours, you see, we just also call the main constructor by saying this, referring to the main constructor. And we are giving it the model that we have been passed in. We are passing it 4 because we know that a saloon has 4 wheels by default, and we know its type of is saloon, so we don't have to specify those. So that makes, so named constructors will make it a bit easy for us. You'll see this in Flutter, where we have to specify different types of thing. So this is just a different type of vehicle. So instead of us declaring and repeating the same 4 tires, 2 tires motorcycle, we can just do a named constructor and say a saloon and give it a model, because model is that varies from one saloon to the next. Like, for example, this saloon and this saloon, the only thing that varies is the type model, and not the type or the number of wheels. So this makes things a bit easy for us, and as that. So that makes work a bit easy for us. So that is that we wanted to cover during the introduction to that. I think the next class we'll be having is synchronous programming, and then I think we can just squeeze in using packages from pub.dev as the next class. So in case there's any other question, any questions from the audience, let's hear them. And I think that is that from me. Ian.
Awesome. Thank you, Danvik, for the insight into beginning with that. And if you have any question to Danvik or any about the program, you can leave your question up with your comment section. Anyone with a question?
So I can see someone with the initials VK. I hope you guys can still hear me.
I can still hear you.
Okay. So someone with the name VK has asked, how can I practice this? So a very good example is just using Datpad, which is just datpad.dev. So you can just go there and start checking out how it works. Maybe in the end, I will share the file that I've been using to reference this specific topic, so that you guys can be able to test it out on datpad.dev. Or as I said, you can just execute by saying, by running from your emulator. You can just run that, then the name of the file. I see another question. Someone is a bit ahead of us, asking that if they have an issue with their Flutter app, and when they add Firebase, it crashes. So you've given an example here. I don't know if this is the proper forum, but basically, JCenter is a code repository for Java, and you need to include it in your build.gradle, I think. Yeah, build.gradle file. So just Google how to include JCenter in your build.gradle file, and also make sure that you have internet. That is usually one of the biggest things that people actually face when they're trying to install to run Android, and the dependencies have not been installed. So check that you have internet. Any other question?
Anybody from the panel on stage has a question? Okay, I guess that will be it. Thank you everyone for the session. And before I end the session, Danvit, do you have or task for us based on what you covered today?
Maybe one of the biggest things that you'll have to do in Flutter is understand basically the understanding how functions work. Basically, the biggest thing I would want us to do is just go and understand how functions work, especially the thing that especially learners in programming will basically face mostly is anonymous functions, passing functions to another function, calling a function from returning a function from another function. Those are the things that you may find challenging in this specific topic. So as a reader head, maybe you can go and look at, you see, Dart and Flutter are all open source. Go and look at how you extend a function, basically inheritance, because you may have done inheritance in another language. It's not very different from any other languages, but just go and maybe do a bit of research on inheritance. In case there's anything else, maybe in the next session you can ask before we kick off the next session. For now, I think the biggest thing is just understand functions and how first order functions are used. And if you can have enough time, you can also look at asynchronous functions. Asynchronous functions is basically a function that will return, it will just basically return some kind of promise, and then it will return a value later. So let's say, for example, you're building a mobile app that you need to fetch information from a server. The information will not be instantaneous the way we've been doing 1+2. It will come in later, so we will have to wait for it. So that's all to do with the asynchronous programming, which will be our next topic. So you can do research on that. And I'll share the script that has all this code so that someone like VK who say that they feel like they have been clutching on a meteorite going at full speed. I will share the file so that it can just be added as maybe I'll create a repo and put the code inside so that you can be able to copy it and paste it on that pad and try to execute, see what is there, experiment, make mistakes, see what the compiler will tell you. I think that's that from me.
Awesome, David, and we appreciate you very much. Thank you. Before I conclude, anybody with a question or a comment? Anyone from the panel on stage?
There doesn't seem to be any.
So okay, I guess that
we have understood. But you see, most of us, some may think that we are a bit behind because maybe we may have learned these concepts, but I think it may be helpful for someone who is transitioning from another language or someone who is new to programming. So feel free to consult within each other and ask any questions if you have.
Awesome. Thank you, David. Now, I just thank you everyone for attending today's session. Thank you for getting time and getting some bundles to be online and get to learn one or two. Special thanks to Danvit. We appreciate you, man, sana. Tunaku appreciate sana for being part of this and helping us understand into the Flutter wave. Thank you, kila mtu, and this session has been recorded. The session will be live, will be on YouTube, will be uploaded on YouTube later. So make sure to search more DSC more, subscribe to our channel so that immediately we upload you into the hype. So Santeni everyone, please share the love, share the Flutter wave, tweet about it, tag us, tag DSC Moi, tag Jidigineri, and let's connect, reach out to more people. Next session will be next Friday, and I hope to see you guys all, and bring a friend, tell a friend to tell a friend. That's all. Thank you all, and please be safe. Wear any mask. Corona is real, and have a wonderful evening. Thank you all. Namaste. Goodbye.